So far we've talked about atoms, atomic number, and ions. What we've got left is isotopes, mass number, and average atomic mass. We'll definitely save average atomic mass until last, so let's start talking about isotopes and mass number, because those guys are related. Isotopes are atoms with, could be ions also, but we'll just say atoms. Now let's fix it. Atoms/ions with the same number of protons but different amounts of neutrons. Prime example of a pair of isotopes is chlorine 35 and let me take a look at this. Chlorine 35 and chlorine 37, I believe. This right here is a mass number. It's the way we distinguish between two isotopes of the same element. Probably a good time to define mass number. Mass number is the total number of particles in a nucleus. Well, there's only two things in a nucleus. That's your protons and your neutrons. So in order to find the total number, what you would do is you would add them up. So your mass number is equal to your protons plus your neutrons. This is always going to be a whole number because you're counting protons. You always have a whole proton, you always have a whole neutron. So this is always going to be a whole number. Always a whole number, and it is not on the periodic table. So it is not found on the periodic table. What people confuse with the mass number is the average atomic mass. I'm not going to say too much about this. The average atomic mass is this number right below the symbol. It's labeled on your periodic table. You can see that a little bit better. Carbon has an average atomic mass of 12.01. That is not the mass number. And in junior high, they might have told you they estimate the mass number by rounding your average atomic mass to the next nearest whole number. Don't do that. That's not the right way to do it. We're not going to do it the incorrect way here. So don't do that. Forget that if you were taught that in junior high physical science. So this is always a whole number, and it's not on the periodic table. The other place you might find this is around the symbol. Might be a good time to take a look at symbols. Let's go ahead and get a new page here. This is something called an extended or complete chemical symbol. what you've got is some sort of general symbol. X doesn't represent any specific element. It's just general. It's an X. It's a variable. It can change. You've got four corners around this variable. Up here, in this corner, you'd find charge. In this corner, you would find the mass number. In this corner, you'd find the atomic number. And this corner we'll get to next chapter more specifically. We're not going to use it much. I'll just point it out. I'm not going to write anything in. In fact, I'm going to erase that arrow in a second. That's where we would find the number of atoms in a particular compound or in a particular molecule. Let me give you a quick example. Something like H2, hydrogen. How many do we have? There's two of them. That 2 down there tells us that's how many. Again, we'll deal more with that next chapter. I just thought I'd put it out there. These are the three corners that we're going to concentrate on. Probably the easiest way to do this is to take a look at a couple of examples. We know that mass number is protons plus neutrons. So we know mass number is protons plus neutrons. We know that the atomic number is the number of protons, and we're going to find that atomic number on the periodic table. And we know that the charge is found by comparing protons and electrons. Again, comparing. We're not going to memorize a formula. Let's go ahead and take a look at an example or two. Let's say we had this symbol here. I had Al with a 3 plus charge and a 13 down here and a 27 up here. And I want to know my number of protons, my number of neutrons, and my number of electrons. Again, I'd probably go for the easy one first. Easy one is my number of protons, my atomic number, right down here. Right down here. Atomic number tells me my number of protons. If this number is blank, then I've got the symbol, and I just look it up on the periodic table, and I see that atomic number is 13. So I know that this has 13 protons right off the bat. One of two ways. I can look here, or I can look here. Tells me my protons. My neutrons, a little trickier. I know that this right here is my protons plus my neutrons. So all I have to do is take away my protons and I'll have my neutrons because that's a grand total. So what plus 13 gives me 27? That would be 14. Or you can just say that 27 is equal to 13 plus n. Again, subtract 13 from both sides, and I get 14. Or the fast, quick way that most people figure out is 27 minus 13, so they're right above each other. 27 minus 13 gives me 14. Electrons, a little trickier. Again, we're making a comparison. So I'm going to look at this first. It's got a positive charge. So I know from my positive charge, positive means that my protons are greater than my electrons. And then I look at this number. So how many more electrons than how many more protons than electrons do I have? 3. Well, if I've got 13 protons, that means I have to have 10 electrons. Because I've got 3 more protons than electrons. My protons are greater. Greater by how much? 3. There we go. 10 electrons. Let's try one more of these. I'd ask for questions, but I know you can't ask them. Actually, tomorrow, Wednesday, I hope to come in for live, and hopefully, if you've got questions, I can answer them. Let's take a look at one more. Let's say I've got something like this, selenium, 2 negative, 79 here. And let's say we don't have anything in that bottom left-hand corner. There's nothing there. Let's say I have to fill that in. I've got to put something in there. And in addition to that, I want to know how many protons, neutrons, and electrons are here. Again, protons are easy. Let's go get them. I grab my periodic table. I look up selenium, and there it is. Selenium. Let me get rid of some of this stuff here. Selenium has an atomic number of 34, which means it has how many protons? Oh, 34. So I'm going to put a 34 in here, 34 here. Probably the next easiest thing to get is my neutrons. Well, 79 minus 34 is going to give me 45. Is that right? 9 minus 4 is 5. 7 minus 3 is 4. So yeah, 45. Let's say that, well, not let's say, I do have to get my electrons. So again, I'm going to look at my negative sign first. That means I've got more electrons than protons this time. And how many more? Well, I'm looking at that 2. It means I've got 2 more electrons than protons. So that's got to be 36 electrons. Let's go the other way. Let's say I've got protons is equal to 21. Let's say I've got neutrons is equal to 24. And I've got electrons equal to 18. And I want to write a symbol for this. Well, to get the symbol, first thing I'm going to do is I'm going to look at the periodic table and find what has 21 protons. 21, 21. There it is, right there. Scandium, 21 protons. So my symbol becomes Sc, scandium. And I'm going to go ahead and put 21 down in the corner here because that's my number of protons. That's my atomic number. Number of neutrons is going to be pretty easy to get at this point because all I know is I got to add up these two numbers right here, add my protons and my neutrons to get my mass number. So that's going to be 45. 21 plus 24 is 45. Charge, a little bit trickier. I've got 21 protons, 18 electrons. So which one's greater, protons or electrons? I hope you guys all shouted out protons. So that's going to give me what kind of charge, positive or negative? My gosh, I hope y'all yelled positive. So that's a positive. Now, how positive is this? Well, I've got 21 and 18, so I've got 3 more protons than electrons, so it should be a positive 3 or a 3 plus charge. Something I want to point out, it is impossible to get your mass number without your neutrons. So you can't get mass number without knowing the number of neutrons. Well, I said you couldn't look those up. You can't look up the mass number. It's not on the periodic table. You can't look up the number of neutrons. It's not on the periodic table. You have to be given that piece of information. Conversely, you can't get the number of neutrons without the mass number. Again, you can't look any of that up. It's something that has to be given to you.